Well, in this video, we are diving into a basic topic in computer graphics and computer vision, which is geometric primitives and transformations. These concepts are the building blocks that enable us to represent and manipulate visual elements in both 2D and 3D spaces. So let's embark on this journey of exploration together. First, we have geometric primitives. So they are like basic shapes that forms the foundation of computer graphics. So they could be a line, they could be a single dot. Actually, we have lots of things like that. So we'll be like discussing about every single types of geometric primitives and its usefulness on the computer vision. So at first we have points. Points are represented by coordinates xy in 2 dimension or xyz in 3 dimension space, and they serve as the simplest element for considering more complex shapes, right? And then we have lines and line segments. Lines and line segments are defined by 2 points or a point and a direction vector. They are crucial for creating shapes and boundaries. So they could be a single direction one, and also they could be a multi-direction one, but the main motto is to be a part of line, that's it. And third, we have polygons or polygons. Anything is actually right. So polygons are closed shape with straight sides like triangle, quadrilateral or square or anything like that, and which actually forms a structural biases, right? So we have a common geometric primitives used in the graphics and vision. So in this picture you can also see a geometric polygon which is formed over here, and it also covers the shape by applying a two-sided dimension all over it to form a three-dimensional structure. And then we have circles and ellipses. Circles and ellipses are defined by a center point and a radii or axis. They add a level of curvature to our geometric toolkit. So the toolkit which I am referring here is nothing but something which is relatable to shapes and structures. So that's why I do say it as a toolkit, okay? And finally, we have curves. There are like plenty types of curves actually. So we also have well-known curves like Bezier curves, spline curves, etc. And other parametric curves help us to represent smooth and intricate shapes. So now we need to understand what geometric transformation is. So geometric transformation are nothing but a function which is probably you're applying on the geometric primitives. So the primitives could be like a line or a shape. So a function like resizing it, scaling it up, or like changing its shapes or orientation, it's what the geometric transformation is. So nothing but a function which is basically you're applying on the geometric primitives. So obviously it involves modifying the position, orientation and scales of geometric primitives. At first we need to see its type, and after that we need to also see the applications. Firstly, we have translation. So translation moves an object by a certain distance along a specified direction. It's like shifting an element from one place to another. And then we have scaling. Probably it's about like changing their size. So we can enlarge the object, we can also delarge the object as per our wish. And then we have shearing. Shearing distorts the shape of an object by stretching or compressing along one or more axes, providing flexibility in design. Reflection mirrors an object across a specified plane, creating symmetrical effect. So it could be like flipping an image from left to right or right to left or up to down or down to up. Affine transformation is basically the combination of translation, rotation, scaling and shearing, offering a comprehensive way to modify the geometric elements. It's basically about the combination of all the functions. Finally, we have projective transformations. So the projective transformations are used for perspective changes in 3D graphics, essentially for creating a realistic scenes. So not only modifying the images in 2 dimension, it also comes to the modification of images or objects in 3 dimension. That's what the projective transformation says. And we also have lots of software to do that. Like for 3D printing, we do use the Tinkercad, and for the architecture we use the Tekla, right? So when it comes to the computer graphics, they are fundamental for rendering 2D and 3D graphics in applications like video games, simulations and virtual reality. Computer aided design, which is CAD actually. In CAD, these principles are employed for designing and modeling out objects in engineering and also architecture, right? And here we are in a conclusion. We actually understood well about what is geometric primitives are and what's the transformation is. Transformation is nothing but the function which we used to do on the primitives, right? So that's what we do call it as geometric transformation. So just stay tuned for the next video where we will go deeper into the computer vision series, and also we'll be like having a practical experience on those kind of topics too. And I'm really excited to build a lot of stuffs together, and as always, thanks for watching.